Hey, Dad.
Hello, son. How are you?
Good. All right, well, we're here in the shop again because this is where we spend our time. So this is the completed intake manifold. And this is the 3D print. I'm happy with the fit. These are the stock injectors, the stock injector rail, which I'm going to have to modify. I couldn't just use stock. I had to modify where the intake and the the fuel in and out were, and then the secondary rail is right there, and I'm pretty happy with that. The next mission is that we're going to. I'm just going to send that out as a file, and I'm going to have it made in nylon 12. It'll be a sintered nylon 12. It'll come back looking pretty much like that, except in a better material. Okay. And then I'm going to wrap it in 2 plies of carbon fiber, and it'll be good. These are the exhaust flanges. These are 304 stainless. I drew these up. I sent them out to Western Steel. They used their laser cutter, and I had them cut custom. And then here, this is a Schedule 40 304 stainless tube, and these are spare parts. These are for the turbo flanges.
Are they in Colorado Springs?
They are. They're local. They're local here in the Springs. They have a really good laser cutter. They also do plasma, and they do water jet, but I think these were all laser cut. Anyway, it's a pretty good deal. They're local, so I used them. So this is all going quite well. This is just a straight print of the engine mount layout. Goes in between the oil pan and the block, and the middle is going to get cut out, and I'm just going to use as much of this stock oiling system as I can, because once you look at that pan, you realize how much engineering went into it.
Yeah, it was,
and
I
don't want to introduce unknowns. Yeah, we moved the gantry, and that's kind of where it's going to live for the moment. And I've been at home working on the buttoning up all the landing gear. I'm pretty happy with where that is, and I'll share some of that CAD a little bit later. But that pile on the table is $7,000 worth of carbon fiber and foam, and that's an airplane right there. Who are you?
Progress is progress.
Who are you? His name is Rick.
Who do you want me to be?
Okay, this is Rick. This is Rick, and we've known each other since 4th grade. And
Long time.
Yep. He builds guns for a living, and used to work at Adam Aircraft. How long did you work at Adam?
9 years.
Okay. What division were you in?
I started with the tooling department. Well, actually, I finished in the tooling department as well. But yeah, I was.
You were there to turn the lights out too.
Pretty much. Yeah, pretty much. Worked around the clock for 9 years. Good. Troy taught me everything I know, and that got me into Adam Aircraft.
So back in the day, we were doing an R&D project here in town, and then that kind of went for about a year, 2 years.
Right.
And then I went back to California. You went to Adam. Katie went off to become an airline pilot.
Right.
Yeah. So that's kind of how that all went down.
Yeah.
Yep. And then, how was it at Adam?
Adam was great. That was a really, really good experience. I didn't expect to be there for more than 3 or 4 years, and I wound up being there for 9. So it taught me a lot. Really enjoyed being in that industry. It was unfortunate it didn't continue, but
yeah,
aircraft industry's tough, as everybody knows.
It's rough. It is rough. It's hard to. You got to be in it because you love it, really. Because sometimes there's no money, but sometimes there is.
Yeah.
But mostly we like to build shit.
Yeah, we're all kind of just builders.
Yep.
Yeah, absolutely.
Yeah. So Rick's been helping me here for the last 4 years on and off. He's got a life, you know.
Truth
We all
be
have a
told,
life.
I've got about 20 hours here. in 4 years, I got about 20 hours in.
Yeah, but I'm hoping you can help me do the quality layups that are coming. Okay, I burned through most of the tooling mostly by myself with some help from Katie and from the boys and from Eston and from you. But when we get into to flight qualified laminates, this is where I'm really going to need your help.
Absolutely. Yep,
Yeah.
That's why I'm here.
So what we're trying to do right now is get this place to the point where we can do laminations we will risk our lives on, and we are not quite there yet. So we need to clean this up. We need to get all the materials organized. We need to get this table so that it will do what it was designed to do, which is prep large chunks of material.
Yeah, it's actually an important part of the tooling process and layup process, and we're using it as a catch-all, so we have to solve that problem.
That's right. So we got a objective for the day: clean this table off. So I'm working on some carts so that we can store this foam, which is our core foam. It's a scored Divinicel style PVC foam. We're using 1/4 and 3/8, and then we have the rack here, and we have our 3K 2x2 twill, and we have our unidirectional material, and there's some glass that we were using for our tooling, and then we have all of our bleeder and our perf and peel ply. And so once we get all of this squared away, we will start prepping, and we'll start by making templates for everything, and then we're going to start small so that we can fail small. We're going to start with small. Yeah. We need to get our lamination chops back up to standard. Right now, we're going to start small.
Yeah, I haven't
fail small.
laid anything up now in 10 years. So
right. So we're going to have to.
It's starting
we're gonna,
over for me,
right.
basically.
It's kind of like riding a bike, but you do have to get up and practice. So we're going to get our chops back up. Start with the stuff that we can afford to fail at, and then work our way into things like wing spars and fuselages and wing skins, and that's really the plan. Mm-hmm. Okay, good.
Sounds good to me.
This is Rick.
Howdy.
Okay, I was asked to explain a little bit about the landing gear, and this design was originally designed for an embedded gear, and thought the better of it, and I have designed what I believe is a pretty efficient retractable landing gear. Now the nose gear folds over almost 180 degrees, not quite 180 degrees. It nests up behind the front seat the front pilot, and in between the legs of the rear seat passenger. It is run off of a linear actuator, as is the main gear. The main gear operates very much like the old an F4F, for instance, where it basically just picks that gear up and nests it into the side of the fuselage. Now, instead of having an open gaping wound in the OML, the door closes completely on top of it. There is no secondary actuator. The gear leg comes up, operates the upper mechanism, and closes the door. There is one actuator, and it runs through the firewall, and that square bar is the torque tube, and that is the main spring. It is a torsion spring, and these are the calculations. This is an online calculator. These are material properties, and that is the deflection under load of that square bar in relationship to the landing loads, and it's designed for 2.5 Gs and about 15 degrees of deflection. So the actuator itself is, again, it's a linear actuator, and it operates both gear legs, and they lock in the up and they lock in the down position. And again, the mainspring is a piece of square spring steel square bar, which is used as a it's keyway stock. So I can get it. It has the material properties that I want, and it transfers the load in torque through this kind of clockwork mechanism. And there is a pin right here that pin is removable. That pin is removable, and this set screw will be nylon, and you pull a lanyard and shear that nylon set screw, and then the mechanism releases itself from the actuator. The springs push it over center and into the locked position, and that's how you get both gear down. Now the gear will probably fall via gravity, but this is let's just call it a gravity assist. And then there is a micro switch for the down position and a micro switch for the up position. There'll be one on each, and there'll be a little bit of logic saying that you're in a safe condition or you're in a transitional position. And this is probably a 10-pound weight penalty, maybe 12 over the other one, but I thought it was a good bet. I thought it was the main reason I did this, I was afraid. It was mostly for ground handling. By the way, these are the cutouts in that main clockwork, in that main arm, to maximize that distance and to keep that from being a stress raiser, and so that you can, machine it, make it machinable. This is where most of the load goes. Actually, all of the load comes up through there and is reacted into those bolts. This is along for the ride. That's the up position. I'm not terribly worried about it. Yeah, everything's tight in here. Anyway, that is kind of an overview of the retractable gear mechanism.